I think we looked at this one in class a couple times too. Always good to review. A person whose height is 6 feet is walking away from the base of a streetlight along a straight path at a rate of 4 feet per second. The height of the streetlight is 15. At what is the rate? So we've definitely got a related rates problem going on here. Let's take a look. Let's draw our picture. 15, 6. So the person is walking away. So this right here needs a label. Probably an X. And then we're asking about the rate of the person's shadow, so let's call that S. And then we've created, I don't know, I guess my basic tutoring point there would be like, just put in the labels that you're talking about. Then we've created some similar triangles. And so similar triangles have similar ratios. This side to this side would be 15 to 6 equals the big side, x plus s to s. Now we've created a relationship that we can put in some of our values. Let's cross multiply, simplify a little bit. 15s equals 6x plus 6s. Subtract the 6x over. 9s equals 6x. Now we can derive the derivative over here will be 9 ds dt equals 6 dx dt, and our goal is to get ds dt, and we know what dx dt is. That was our 4 feet per second. So ds dt equals 6 times 4 divided by 9, which I think is, on my calculator, 2.667. All right, we've got someone moving along a line again. Here he is, this person walking in a path so that his acceleration after 0 is given as this. If the person's velocity at 0 is 5, so they're already moving, what is their velocity at 3? So they're going 5, and they're adding some acceleration. That's how we add. There we go. 0 to 3. Put that in my calculator. And I think this was the second time this happened. This value is 6.7. But see that 710 there? It only shows up in those two problems. And then if I add the 5, I do get the final answer of 11.710. I don't know, just something to keep an eye on maybe. Looking at 90. Let f be a function such that the integral from 6 to 12 of f of 2x equals dx equals 10. Which of the following must be true? So in order to anti-differentiate this, we would have to do a u substitution. U would be 2x, and du would be 2. So if I've got a 2 here, I need a 1/2 in front. And then my limits would get changed. If x is 6, then u is 12. If x is 12, then u is 24. I'm just putting in those bounds. So let's take a look. 1/2, the integral from 12 to 24 of f of u still equals 10. All right, but that doesn't show up anywhere. I've got 5s and 20s. But what if I multiply the 1/2 over? If I multiply everything by 2, then I get it equal to 20, and then I'm all set. Definitely advanced u substitution type problem, I'd say. All right, 91. We've got our polynomial function with a graph. Any time we get a table of values, I'm encouraging you to make a graph. 3, 1, 4, 7, and 6, and 5. All right, we've got our graph in there. Must be true again. The graph is concave up. So this is the derivative. For me to have the derivative and know the graph is concave up, the derivative would have to be increasing. It's definitely increasing from here to here, but it's definitely decreasing at some point. So that's not concave up all the time. It has some concavity up for sure, but I wouldn't say all the time. Has at least 2 points of inflection. So for the graph to have at least 2 points of inflection, that would mean that, again, f prime changes from increasing to decreasing, or from decreasing to increasing at least twice. And does that happen? It definitely decreases to here and then increases, and it's increasing here and then decreases. So that happens twice, for sure. At least. F is increasing. Well, the derivative, according to my sketch, is always positive, but obviously we also understand that we were only given some values, so it could go, we could get anything going on here. So it could go negative at some point. So I'd say you couldn't say that it must be true. No critical points. Again, based on my graph, it wouldn't have any critical points, but it could. We don't know. It's not a must. And 2 relative extrema, well, those are our critical points again. It could have none, it could have a bunch, but there's no must be true. So we've got our must have 2 points of inflection. That's all we got to go. All right, and then finally 92. I hope you stuck around this long. Got an easy one here. The region in the first quadrant bound by x squared and the square root of x. Where this is the base of a solid whose cross sections perpendicular to the x-axis, which we like, are squares. What is the volume of the solid? So there's the base of the square. There's the height of the square. So what is this length right here? What is this length right here? It's got to be top minus bottom. So square root of x minus x squared. That's top minus bottom. If it's the area of a square, squared. From 0 to, and if we found the intersection, that's 1. Plugging that into our calculator, we should get this, which is actually really close to that. I guess it's just moving up decimal. Good job. Keep it up.